Okay, so we talked about this before, okay? And we said that if I want to convert this factored form into standard form, what do I have to do? FOIL. What do we call the process? FOIL is the acronym, right, for expanding, right? So the process is called expanding, okay? But the method is FOIL. Okay, so let's FOIL. What do we do to FOIL?
Just multiply the first by the first of the one.
So I'm going to leave the 3 outside for now. And then I'm going to multiply this, then this, then this, then negative 2 times 1. So x times x is x squared, x times 1 is 1x, negative 2 times x is negative 2x, and then negative 2 times 1 is negative 2. Then what do I do?
Multiply by 3 by the same.
So I can collect terms or I can distribute and then collect. It doesn't matter which one to do. Okay? So we can collect like terms inside the bracket first, just because BEDMAS says so. It's going to give you the same answer no matter what you do. And then you're going to have to distribute that 3 into each term inside the bracket. So that gives you 3x squared minus 3x minus 6. Good? Okay. Can I ask you guys a question? So this is the expanded form. We call that the standard form, yes? So that looks like y equals ax squared plus bx plus c, where I have the 3 terms, right? If you are going to look at this format and look at your properties, which one of your properties, I think this is similar to none of these, is it? Okay, never mind. I wanted to combine 2 things together, but I don't see it in here. We don't have the graph for this. We'll talk about that in a bit, okay? So here's why we need to know how to factor. If I want a graph, right, I need to find my zeros so I can graph it. If it's not in vertex form, we learned how to do the vertex form, right? We learned if you have the vertex form, you find the vertex, you do your graphing by doing step pattern. Good. But what if I have this, which is the standard form, and it's asking me to find the zeros of the relation? Can I find the zeros right away from the standard form? What do I have to do?
You have to do the process that products plus sum, right?
Okay, so I have to factor, right? And then once I factor, I can solve for my zeros. Okay, so let's do that. How do I factor this thing? What did we say? What's the first question you always ask yourself? Do I have a common factor? Yes. What is it? Negative 3, guys. When it's a negative in the A, you must factor the negative out. Okay? So if I divide by negative 3, negative 3, negative 3, what do I get? X squared.
Negative minus 8x. And plus
Is it 8? Yes. And then positive 16. Okay? Now you can do your sum and product. What am I looking for? 2 numbers that multiply to 16, add to negative 8. Product is 16, and the sum is negative 8. What multiplies to 16 and add to negative 8?
4 and 4.
They add to negative 8, 4 and 4?
No, they have to be negative.
Both negative. Remember the green sheet? Your B is negative and your C is positive. So both factors have to be
So we keep this
negative.
on the test.
Yes. You don't want it?
I love it.
Okay. 'Cause I can. You don't have to use it then. So y equals negative 3, x minus 4, x minus 4. So the question is asking me what are my zeros? So set this equal to 0, sorry. So how many zeros here since I'm going to get the same answer for both of them?
1, 0.
1, 0. You're going to have the case where it's going to be like this. Nope. Look at this. It's going to open down, but it's going to be the vertex as well.
Oh, okay.
So this is the case where you're going to have only 1, 0 because it's the same thing. It's happening twice. It's the same 0, right? It's going to open downward because it's a negative 3, the A value, right? What? What?
I don't know. It's good. It's good. We never see the vortex on the apps.
Yes, we do.
Yeah.
Should I show you one?
No, okay.
Here.
Okay, cool.
What if you have this? If I want to look at this and I have k is 0, what's your vertex?
0.
No.
X equals
5,
5 and 0.
0, right?
Yeah.
So my vertex is 5, 0, and my step pattern is 1, 3, 5, yes? That's where my vertex is. Going up 1 over 1. Up 3 over 1, yeah? So is this? In this case, you only have, instead of having this, right? The only thing you have is a vertical translation, or sorry, horizontal translation, 5 units to the right, right? So you do have this case. And technically speaking, if I want to write this here, I can actually write it this way. You don't have to write that. I'm going to erase it. I can write it like this. Yes? Because I have x minus 4 multiplied by itself.
What happened with the 3? The number 3?
Still right there. The number 3 is only going to affect your graph vertically stretch and vertically compress. Like in this case, the vertical stretch with a reflection. Okay? How can I factor that one?
negative 6 is factor.
Negative 6 is a common factor. Okay. So if I factor out a negative 6, what do I have left? 4x squared minus 1. Can I factor this any further?
Yes.
What? How?
2x plus 1 difference.
Difference of squares, yes. So what would it be?
2x plus 1 and 2x minus 1.
Anyone have problem with this? So it's the square root of 4x squared. Square root of 4 is 2. Square root of x squared is x. Square root of 1 is 1. Okay? So I did the difference of squares here. Okay, what are my zeros? Because that's what the question is asking you for.
Negative 1 and 1. 1 by 2. Negative 1 by 2.
Remember, I never told you that's only the opposite, right? I always said it, and I always isolate for x. Okay? So let's set it equal to 0. If I set this equal to 0, what do you get? 2x equals negative 1 And then divided by 2, because you want to get rid of that too. So that's x equals to -1/2. And that's why we need to set it equal to 0. We need to actually do the work. Same with this. Set it equal to 0. Bring the -1 over. Then divide by 2. So my two zeros are -1/2 and 1/2. Okay? So basically, if I'm going to graph this, one of my zeros is going to be at -1/2, the other zero is going to be at 1/2, and then this is going to open down, so it's going to look like this. Are we good? Don't rush things. Write things down so you don't make mistakes. Okay? Okay, we're going to do the C and then we're going to stop right there.
So how did we come up, I forgot, how did we come up with the starting point on y? It's 6? No.
What do you mean? The initial value?
Yeah.
The initial value you have to plug in as, it is 6 for this one, yes. But we haven't talked about that yet.
Okay, because I was just looking at the graph that
Yep.
how did it start?
Yeah, but we don't need to talk about that yet. Okay, but you're right, it is at 6. Okay. Do you guys have any questions about this? All right, so let's look at C. I have y equals -4x squared plus 24x, and it's asking you to find the zeros of the relation. What do I want to do?
Common factor
What would be your common factor? I heard you guys.
minus
-4x. I can
24. Oh, I saw it was 2 only.
yeah. So I can divide both by -4, and then x is a common term. Yes? If you look, the first one has an x squared, the second one has an x. So if I divide by -4x, so that's my common factor, that I'll have x minus 6. Is that right? Okay. What are my zeros?
X equals 6. You have 1, and then x equals 0,
And why is that?
because there is 4x, -4x also there. So -4x equals to 0, and then if we divide it by -4, it's still going to be 0. So x equals to 0, and x equals to 6.
Guys, look at me for a second, please. You see that x here? You shouldn't treat it as an as an abandoned child. It's there. If I set it equal to 0, if I set this equal to 0, this x here can also be 0. This is technically writing this, but I don't write it. Because I don't write x minus 0. It means not like, why are you making it even harder on yourself? Okay? That's why we don't write this. But technically speaking, this is the same thing as what I just wrote right here. Okay? Like, I can't tell you how many times. A question like this is going to be on the test, and I'm telling you that from now. And I can't tell you how many times students have missed one of the zeros, have missed the 0 as a 0. Okay? And then the whole question is wrong, because now they have only one 0, right? Which is going to become the vertex. Then your graph is going to be all wrong. Instead of being like this, right? What they have this. That's totally different. These are different graphs, okay? So please don't miss this x can equal to 0. And then you have the x minus 6 equals 0, so x equals to 6. So in this case, you have two zeros. One of them is at the origin, the other one is at 6, and this opens down because it's a negative. So you're going to have this kind of graph. Do we get this? Are we going to forget the 0?
Yes.
Okay, so I'm going to stop.